Hi student. So in this session we are going to discuss about the topic anodic protection from unit 6 corrosion science. The learning outcomes from this session will be students should be able to explain active passive behavior of the metal. They should explain protection of metal by anodic protection method. Now, anodic protection is the method of metallic protection in which the metal to be protected is forced to behave as an anode by applying external potential, and this potential applied should be in the passivity potential range. Now here the question will come in our mind that what is passivity potential? The passivity potential is the potential in case of certain metals like aluminium, chromium. Such kind of metal shows passivity in certain range of potential. That means in this range of potential the metal is non-corroding in nature. The corroding environment will not corrode the metal in this potential range. Here it has been seen that every metal has such kind of passivity potential property, but not all the metals have broad range of passivity potential, and these metals which are having broad range of passivity potential, this property of passivity in certain potential range is used to protect the metal from the corrosion, and such method of corrosion protection is called as a anodic potential. So this anodic protection is applied to the metal which is having broad range of passivity potential, and at this potential range the metal becomes passive towards corrosion. Now this active passive behavior of metal can be discussed by using this diagram. So here in this graph the x-axis corresponds to the corrosion rate of a metal, while y-axis corresponds to the electrode potential applied to the metal. If you see this graph, then you will observe that at initial value of the potential applied there is a rise in the rate of corrosion. So the corrosion rate increases with increase in the potential, electrode potential. After some time there is a decrease in the corrosion rate if you go on increasing the electrode potential, and if you can see this range where there is no change, there is no increase in the corrosion range, and this range is called as a passive range of the potential and called as a passivity potential. After this passivity potential, if you increase the electrode potential, then the metal will again show increase in the rate of corrosion. So with respect to the applied electrode potential, there are three zones which will show different behavior, corrosion behavior to the metal. The first will be the active zone in which the corrosion will occur, that is the initial zone. After active zone there will be a passive zone. In this zone, when the potential is applied, the metal is not prone to the corrosion, and after this zone there is again transpassive zone in which the corrosion of metal occurs. So this passivity potential range for metals like aluminum and chromium is broad, and this is not the same with all metals. So only the metals which is having broad range of passivity potential can be protected from the corrosion by the anodic protection method. Now this diagram will explain us how the anodic protection is carried out. Suppose there is a metallic tank which consisting of a highly corrosive liquid electrolytic solution, and we want to protect this tank from the corrosion. Now this tank can be protected from the corrosion by using the anodic protection. So here this tank can be made as anode by connecting this tank to the anodic end of the potentiostat, and with respect to this reference electrode, the metallic structure, the tank is made as a anode. So here the metallic tank is converted into the anode with the help of a reference electrode. Now to this metallic structure a passivity potential is applied, which will be measured by this voltmeter, which will be maintained by this voltmeter, while there is a third electrode which is called as a auxiliary electrode. It is connected to the tank and the potentiostat. So this auxiliary electrode will measure the corrosion current. So null deflection in case of the ammeter which is connected in between the auxiliary electrode and the potentiostat indicates the corrosion current is 0 and the tank is protected from the corrosion. Any deviation in the ammeter reading other than null deflection will indicate there is a corrosion occurring with the tank. So simply the tank is made as anode by connecting to the anodic end of the potentiostat, and with respect to the reference electrode it is converted into anode. Here the reference electrode used must be made up of a metal which is having very low corrosion tendency. The metal like platinum will be used as a reference electrode, while the auxiliary electrode which will measure the corrosion current is made up of a graphite. Now again we will see the construction of this anodic protection. So the corrosion control by this method is achieved by making the metal anodic and applying passivity potential with respect to the metal. Construction and working. So by using reference electrode and auxiliary electrode, the metallic structure under protection is made as anodic in nature. The potentiostat is used to provide the desired passivity potential and is measured by the voltmeter. Ammeter measures the corrosion current which is connected to the auxiliary electrode made up of a graphite. Minimum or negligible current by ammeter indicates the protection of a metal by anodic protection method. The graphite is used as an auxiliary electrode, and the cathodic metal used is high corrosion resistance metal like platinum. Now applications of anodic protection. For protection of chemical reactors, for protection of water coolers and metal condensers in industries, complex metallic structures above and underground can be protected by using this anodic protection. Pipelines carrying corrosive liquids or corrosive solutions can be protected by using the anodic protection. Advantages: this method is applicable to highly corrosive environment. Operating cost is low. Feasibility of the method can be predicted in the laboratory. It is a unserving method to protect the complex structures. Corrosion rate can be predicted by value of protection current. That means by knowing the ammeter reading we can control the corrosion rate. Limitations of this method: only few metals which shows active passive behavior can be protected by this method. high starting current and installation cost for this method. High rate of corrosion will be observed if the system goes out of control. So in summary, we have discussed about active passive behavior of a metal, definition of anodic protection, construction and working of anodic protection method, application, advantages and limitations of anodic protection. Thank you for watching this video.